This video covers Module 10 Homework 2. It's talking about graphing linear inequalities. So before we even start with this, just like normal inequalities on a number line, we have different symbols. So greater than and less than. Remember, those are not included, meaning the numbers that we're talking about are not included in the set. So when that happens, in order to show that for these lines, we're going to show this by doing a dotted line. So the numbers on the line are not included. Same concept, if it's greater than or equal to or less than or equal to, those numbers are included that are on the line. So we're going to show this by using a solid line. So starting with this first one, we have x minus y is greater than or equal to 7. So for one, just by looking at this, we know we're going to have a solid line. So we're going to start by graphing. X minus y is greater than or equal to 7. I need to get it in y equals mx plus b slope-intercept form, so we want to get y by itself. We're going to subtract x. Negative y is greater than or equal to negative x plus 7. Last but not least, we're going to divide by negative 1. So we're left with y. Whenever we multiply or divide by a negative, don't forget to flip the sign. We divided by a negative, so flip sign. So now it's y is less than or equal to negative x divided by negative 1 plus 7 divided by negative 1, which will give us x is less than or equal to positive x minus 7. So now we know it's a solid line like we talked about. Our slope is 1, which is the same thing as 1 over 1. So we're going to rise 1, we're going to go up 1, and we're going to run 1. So that means we're going to go to the right 1. From our starting point, 0, negative 7. So 0, negative 7. 1, 2, 3, 4, 5, 6, 7 is our starting point, is our y-intercept. So from there, we're going to go up 1 over 1. Up 1 over 1. Up 1 over 1. So now all of these points that lie along this line are part of this set, are included, and they are going to show this by using a solid regular line. A solid regular line. So the other thing with this, so it's saying everything that x minus y value is greater than or equal to 7, it's talking about a whole region. So I have to see if you can see that this line splits this graph up into two regions, this upper region and this lower region. So I want to see which one are we talking about here. So the easiest way is we can test a point. So I usually test 0, 0, as long as 0, 0 is not included on the point, on the line, which is not. So I'm testing this point right here. I'm testing to see if this region works. So when I plug in 0, 0, 0 is for x, minus 0 is for y, is greater than or equal to 7. 0 is not greater than or equal to 7. So that means this region did not work. So that means this region has to work. This region gets shaded. And that's our answer for this first one. Same thing for the next graph. 2x plus y is greater than 4. This one, just greater than, so that means we're going to have a dotted line. Those points are not included, that line on that line. I'm going to solve for y to get it in slope-intercept form, so I'm going to subtract 2x. Y is greater than negative 2x plus 4. That means our slope is negative 2, which is negative 2 over 1. That means we're going to rise negative 2 or go down 2. And we are going to run 1, which means go to the right 1. From our starting point of over 0 up 4. So over 0 up 4 is our starting point. From here, we're going to go down 2, right 1. Down 2, right 1. Down 2, right 1. So there's a couple points that help us to graph it properly. So now, like we said, a dotted line to show that these points are not included. Mine's more like a dashed line, but you get the point. A dashed line, a dotted line. In my math lab, it has the option of solid or dotted. And then now we need to test to see, okay, does this region work or does this region work? So again, I want to test 0, 0. You can test any point that you want. That's just the easiest point to plug in for me, in my opinion. So I have 2, x is 0, plus y is 0 is greater than 4. So 0 plus 0 is greater than 4. 0 is greater than 4. Nope, that did not work either. So that means this side did not work. So that means this side has to work, so it's going to be shaded. And that's our answer. Next page. We have y is less than or equal to 4x. So this tells me we're going to have a solid line. This is already in slope-intercept form for me. It's the same thing as 4x plus 0. So I know 0, 0 is my starting point. And our slope is 4, which is 4 over 1. So that means we're going to rise or go up 4. And we are going to run or go to the right 1. So starting at 0, 0. We're going to rise 4, 1, 2, 3, 4, and we're going to run 1. So up 1, 2, 3, 4, over 1. And we said we're going to have a solid line. Solid line, there we go. Now I want to test, does this side work or does this side work? Now, 0, 0 is on the line, so it's not telling me one side or the other, so I have to pick another point, any point. Let's pick 1, 1, I don't know. So testing 1, 1. So y value is 1, less than or equal to 4, times our x value is 1. 1 is less than or equal to 4. That is true. That's a true statement. So that means I want to shade the side that includes 1, 1. So this side, this 1, 1 worked. So I want to shade the side that includes 1, 1. I know my shading is beautiful. Whatever. And that's it. Let's keep it rolling. 2x plus 6y is greater than negative 30. So again, just by looking at this, I know it's just greater, so it's going to be a dotted line. I know it's going to be a dotted line. I want to solve for y to get in slope-intercept form, so that means I'm going to subtract 2x from both sides. So 6y is greater than negative 2x minus 30. Dividing by 6, we have y is greater than, we're dividing by a positive number, so we don't change the sign. Negative 2x over 6 minus 30 over 6, which can be simplified to y is greater than negative 2 over 6, have a 2 in common, so I can simplify that to negative 1/3. X minus 30 divided by 6 is 5. So now I know my slope is negative 1 over 3. So I'm going to rise negative 1, which means I'm going to go down 1. And I'm going to run positive 3, which means right 3. And our starting point is 0, negative 5. 0, negative 5. So starting at 0, negative 5, 1, 2, 3, 4, 5, over 0, down negative 5. And from there, I'm going to go down 1, right 3. Down 1, right 1, 2, 3. Down 1, right 1, 2, 3. Down 1, 1, 2, 3. And we said we're going to have a dotted line, so we're going to connect the dots with a dotted line. There we go. And now we're going to test the point. So I have two regions, this upper region and this lower region. Pick any point that's not on the line. I'm going to pick 0, 0 because that's the easiest point for me to plug in. So we're going to test 0, 0. So 2x, so 2 times 0, plus 6y, 6 times 0, is greater than negative 30. 2 times 0 is 0, plus 6 times 0 is 0, is greater than negative 30, which will lead me to 0 is greater than negative 30. That is true. 0 is greater than negative 30. So that means this side with 0, 0 works. So all of this upper region gets shaded. And that's it. Last two. We have y is greater than or equal to negative 1. This is our special case. So we have, for 1, it's greater than or equal to, so we know it's going to be a solid line. We have y is greater than or equal to negative 1. So we know it's going to be a horizontal line at y equals negative 1, and it's going to be solid. Oy. There we go. Same concept. I have two regions, the upper region, the lower region. I need to test a point. Test any point. I'm going to pick 0, 0. So my y value is 0 is greater than or equal to negative 1. That is true. 0 is greater than or equal to negative 1. So that means I want to shade the side that includes 0, 0, which is up top. This side works. We're good to go. Last one. X is greater than negative 4. It's just greater, so that means those numbers on the line are not included. It's going to be a dotted line at x equals negative 4. X equals negative 4 is a vertical up and down line. X equals negative 4, special case, it's dotted. Same thing, two separate regions, the left side and the right side. I want to test a point, test any point. I want to pick 0, 0 because 0, 0 is not on the line. So x is 0 is greater than negative 4. Yes, that is true. So we are going to shade the side that includes 0, 0. And that's it. Let me make sure. Yep. And that's it. So that's all of Module 10, Homework 2.